This is Bob Belair. I brought the Waveguide 1. It's the original Waveguide. I've done a number of other ones to understanding this, but this is the very first one. It's a transmission line type of speaker. It has 5-foot transmission line that's tuned to 32 hertz, but it has 8.5 feet of compressing tunnels to get to the 5 feet. The tuning is 32 hertz. The free air resonance of the driver is 35 hertz. The driver is a Tang band 8-inch underhung. It's a strange animal with 2-inch voice coil. It's mid-bass. It's only 35 hertz free air resonance, so it's not expected to get bass. But it had underhung capabilities. 8mm X-Max is all I really needed. The problem was it was so big, the magnet comes through the back of the cabinet. You'll see that it had to be siliconed in place. And then the voice coil vent was coming right out the back, and it ended up being so large of amount of air, then it was vibrating the tweeter pod. So then I had to put a 90-degree elbow on the back, glued on the back of the speaker magnet, and then it went down to the floor. But then at 20, 25, 30 hertz, the chuffing and buzzing from the voice coil was so bad that I had to design a muffler. So now I have a tube lined with fiberfill that straps on to that corner reflector, and now I have a muffler to get rid of chuffing. Now that cabinet was the first one. I made it out of scrap. I didn't know if it was going to work or not. I designed it from the seat of my pants, doing it full scale on a drawing board, erasing and erasing until I got what I felt was going to work. And then I had to make the cabinet bigger by increasing the depth, but I eventually got something to work. And I changed a mid-bass into a woofer. It goes down solidly to 25 hertz. And then I had to come up with a tweeter pod. Now the tweeter pod, I bought the AMT to go along with the woofer, but it has a rising response that then rolls off too fast. So it had to be turned into a mid-range. I put a single 0.4 millihenry coil to flatten out the response and then roll it off. And then I brought in the Beston ribbon tweeters to fill in the high end. Now you notice the tweeters are side by side, what you don't ever do. But I was worried about parallax, and I went into it. I always try. I don't just go by the no-nos, so I tried it. And if you bend them around and locate their focal point to the mid-range cabinet, they eliminates the parallax. There is no jump or shift as you go from tweeter to tweeter. There's also no jump and shift as you go from the tweeter to the mid-range. Even though it's a first order, big overlapping crossover, there is no parallax problems. So everything is a holographic image on the high end. Now I have to exploit both of these. The spherical time alignment is going to be exploited to another degree. And also the waveguide reflex is going to be exploited to a higher degree. But this is the start. This is where I started from. I got stuff on the drawing board that's very exciting. I'll see you next year.
Hi, I'm Todd. I did the TK1 Satori 10.1 build in the over 300 category. It is a sealed enclosure with the Satori WO24P 8-ohm version as the woofer, and the tweeter is the SB Acoustics SB26 ST Waveguide 4 ohms. The front baffle has a 3/4 inch step down for the tweeter for time alignment. The baffle itself is 3 layers thick on the woofer side and 2 layers on the tweeter. The thing that I wanted to do with this project was do a 1.5 inch radius on the whole front baffle with a stepped baffle, which was kind of difficult. I had to split the front baffle and fill it in 2 different steps. It smelled like burnt MDF when I did that. The enclosure is 33 liters sealed with 2 horizontal braces and 1 vertical brace. The cabinet is lined with the 3/4 inch damping material available at Parts Express. I also have a Dynamat layer under that throughout the whole enclosure. And then there is some additional stuffing. The FB is 45 hertz, and the minimum impedance is 6.3 ohms. For the crossover, I tried to design LR4 network at 1.4 kilohertz. It ended up being a little lower than that. I used Jansen air core inductors and cross caps.
Hey, so I'm Dan Watson, and this year to the Parts Express competition, I brought the Quattroportes to the competition in the over $300 class. And while it was the over $300 class, all the drivers on it were free to me. So it was a pile of parts looking for a project. And so when you're trying to start up a speaker project, there's so many choices. You have to limit the variables. So limiting it to what I had on hand really helped kickstart my design progress. Taking basic frequency responses of all the drivers, seeing where they shine, seeing where they were poor performing. And I had a pair of woofers that I actually got from Parts Express at the speaker design competition last year, the Epic E180s, which are their subwoofer woofers that can extend into the mid-range. So I wanted to use those at the Parts Express competition. And then I also had a pair of tweeters that a friend found salvage for me and was kind enough to gift me. And listening to the tweeters, they really shined off axis. So not listening straight in front of them, but stepping to the side. And the tweeters were beautiful off axis. So I wanted a design that would force the listener to be off axis from the tweeters. So if you look at the Quattroporte, they are floor standers, but they're short floor standers. And they're tilted back about 18 degrees, which just happened to be, what the materials I had on hand worked for. So they're tilted back 18 degrees. They're meant to be listened, very wide stage, straight ahead. So you're listening kind of in the center, but 30 degrees off axis, both horizontally and vertically. And they really shined with a basic passive crossover setup, some parallel notch filters on the tweeters, some funky Zobel compensation on the woofers. But really, I put them together. I think I got the crossover mostly right first shot, and I finished them at about 1 or 2 a.m. Friday morning before the Saturday competition, and then I had to drive 7 hours. So here at Parts Express is the first time I really got to listen to them, and the feedback I've gotten from competitors, from Parts Express staff has been amazing. Some of the staff here knew a lot more details about the tweeters I used than I knew because they were salvage finds. I had no information on them, but the knowledge base here has really helped kind of put together a full picture of what the speakers are about. So thank you for your time.
My name is Jack Putti. My over $300 project is called Black Orpheus. I got that name from an art film from the 1960s called Black Orpheus. And I'm a jazz fan, and there was an album by Vince Guaraldi of Peanuts fame called Jazz Impressions of Black Orpheus, and so I thought it was fitting. My goal there was to use a Tang band full range with a small, what they call a subwoofer, but it's a 5.5 inch driver. And the crossover frequency is very low, and they're basically going to be in a very small room, probably on a desktop. They were built for my son-in-law, and so that was kind of the challenge for these, was to the kind of the opposite of the under 300s that I did. I have a very low crossover frequency here also, but it's a full range. So I wasn't worried about the high-end dispersion because of the fact that they would be used in an office. So that's kind of the impetus for those. And I chose to paint them lacquer black, and that was a mistake because I had to paint them probably 6 times before I got them halfway decent. So I have to learn how to paint, but I think they turned out very well and they sound really good. So thank you.
Hi, I'm James Polk, and my project I brought is the JP Cubit Spires. And where that name came from, when in the Bible, when God was telling Noah what dimensions to build the ark, he said so many cubits by so many cubits. And since the main part of my speaker is a cube, I thought I'd, a little play on words. And the spires are 2 pieces of black walnut. I turned myself on my brother-in-law's lathe. And a spire is just something that sticks up in the air, a structure that sticks up in the air. So Cubit Spires. They're basically a build out of whole cloth. Nothing really inspired me to do these. I saw after we turned those black walnut dowels, I thought, what am I going to do with these? And then I got to thinking stereo speakers, so it kind of evolved from there. The body of the cube is veneered birch plywood, and then I puttied in all the edges, tried to make it as smooth and cube-like as I could. The look I was going for was textured leather, and I think I came pretty close. Had a 12-inch woofer, active woofer in the front. It's a gold wood. A Dayton 12-inch passive radiator on one side, and 2 8-inch passive radiators that I got off eBay from a guy in Hong Kong. The mid-range and tweeter are GRS 10-inch and 8-inch flat panels. And the crossover network was my first attempt at ever building a crossover network from scratch. I used Solon caps, and I overlapped all the frequencies between the drivers, and I think it came out pretty good. Okay, thank you very much.
All right, my name is Keith Etheridge, and I brought the Chimera speaker design to the Midwest Audio Fest this year. It is a mass-loaded transmission line design, but all that really means is that it's a bass reflex cabinet with some stuffing in the upper 60% of it. I decided to build that this year after being contacted by the folks at Chimera, and they sent me some drivers asking if I would be interested in doing a DIY build, since Parts Express recently started carrying those drivers, and naturally I said yes, absolutely. The reason it's called a Chimera design is in Greek mythology, a chimera is a creature that has the head of a lion, the body of a goat, and the tail of a serpent. And Chimera sent me a home product line woofer, a car product line mid, and a pro product line tweeter. So names seem to fit pretty well. Wasn't planning on doing a build for this particular competition, but when opportunity knocks, I say okay, especially when speakers are involved. So I'm really excited to see how they do in the judges' room later and get some feedback on what people think about the design overall. It's the second 3-way design I've ever done.
My name is Patrick Griffith. My project is the Jazz Kissa. Kind of an odd name, but got that inspiration from Japanese critical listening cafes in Japan. Kind of interesting concept. They're cafes where you go, instead of drinking coffee, you go and play music, listen to records. So yeah, a lot of vintage equipment, which kind of borrowed the idea from my speakers. Classic 3-way. Growing up in the late 80s, early 90s, that's pretty much what speakers look like. So kind of worked off that inspiration. Made them look like what in my mind I remembered having in my living room growing up. So that's what I went with. Construction of the cabinet, it's a basic 3/4 inch MDF for the sides, back, top and bottom, and then a 1-inch piece of red oak for the front baffle. The speakers inside are from the tweeter. I've got a Peerless XT25 TG30. The mid-range is an RS 150p from Dayton Audio. And then the woofer is a 10-inch Peerless NE265W. It's very hard to get all those to work properly together. This is my first 3-way design. But in the end, I'm really happy with them. I think they turned out well. So, yeah.
Hi, I'm Paul Kittinger. Been doing DIY speakers for probably 20 years now. I brought my Verismo design this year. It's a three-way TMWW. Uses a GRS RT1 tweeter, a Morel MDM 55 mid-range, dual mid-range, and a pair of Dayton Audio ES 140 TIAs, no longer available. Too bad. The basic design for the woofers is a mass-loaded transmission line. Inside the cabinet is a 30-inch separate chamber, a 30-inch tall separate chamber. And the line is a single fold 2-segment line, so it's 5 feet long. The modeled expected anechoic F3 is, 32 hertz. Overall sensitivity is about 86 dB, maybe 87. Dan Neubecker designed the crossover. Corners are at 900 hertz and 3 kilohertz. The cabinet itself, the outside panels are all 3/4 inch solid bamboo. It's a nice wood to work with. It's really not wood, it's grass, but it saves a lot of work on sanding because it's pretty smooth to begin with.
Hi, I'm Todd. I did the TK1 Revelator 5.1 speaker project in the over $300 category. The two woofers I used were the ScanSpeak 15W 4-ohm version for the midwoofer. The tweeter is the SB Acoustics SB29 RDNC ring dome tweeter. It's a 29 millimeter ring. I did a ported design in 9 1/3 liters. I guess the feature of this build is the 3D printed baffle. That allowed me to give the baffle angle and facets and also the fillets. The tuning frequency is 50 hertz, minimum impedance 3.6 ohms. The crossover is asymmetrical, second order on the woofer, third order on the tweeter. Parts I used were Jansen and Dayton inductors, air core inductors, and Jansen cross caps. This project started as a gift from my cousin. I ended up doing 3 revisions, and this is the 3rd revision. I went through, the first design had a different woofer and a passive radiator. The second design had a different woofer and 2 passive radiators. And then I arrived at this design using just a standard ported design. The port on this, I was able to reduce some of the resonance by drilling through the port and then damping over that with some damping material felt. I cut the port resonance by about 7 dB, and it was a cool project to see that happen just by modifying the physical port.
My name is Bill Schwefel, and I brought the Retrospeak speakers, and they're kind of a speaker that used drivers that were 20 to 30 years old. The tweeter is a Morel MDT-33. Morel sold those as a match pair back in the mid-1990s. And the mid-range is a Vifa D75, and that's about 20 to 30 years old also. And then the third speaker I'm using is it's the Dayton RS270P, the paper version. It's a 10-inch woofer. And crossover frequencies are approximately 750 between the woofer and the mid-range, and about 3,500 to 4,000 hertz between the tweeter and the mid-range. And the system was designed using the V2X CAD software package, using a full spinorama set of data. So what I did is I set up my microphone in my great room, and I have a turntable where I spin the speaker around 180 degrees, taking a whole bunch of measurements. And then you feed all these measurements into the V2X CAD software package and develop a crossover. And the cabinet is constructed of solid woods. There's no MDF, no plywood, no particle board. The front baffle is a solid 3/4 inch curly maple, the front and back, and then the side panels are solid mahogany. That's Retrospeak, and the tuning of the woofer in the cabinet is at right around 27 to 29 hertz, the FB tuning. That's about it.